Hello and welcome to Honors Function. In this video, I will go over problem 5 from class assignment 7. In this problem, you're given 2 points, A and B, and you're first asked to find two other points, X and Y, such that ABXY forms a square with AB as one of its sides. Alright, so I always suggest a geometrical approach whenever possible. When you are given coordinate of a point or a line or a geometrical shape, you must have a geometrical approach, okay? Alright, so let's plot the point and let's understand what's going on. Alright, so this is a segment AB right here. I'm going to draw the square that is below the segment. Okay, I'm going to draw the square that is below the segment. So, how are you going to find the coordinate of X and Y? Well, you know that in a square, sides are perpendicular. Therefore, you want to find the perpendicular slope to AB, so you can move on the perpendicular line, okay? So, what is the slope of AB? Let's see. Slope of AB is your run is 6, your rise is 2. So the slope of AB is 2 over 6. Therefore, the slope of the perpendicular to AB is going to be negative 6 over 2. Where am I going to put the negative sign? Well, let's see. I want to go down, right? So it's negative 6 over 2. If you were to use the slope 6 over negative 2, you would be drawing the square above, because you would be going up 6 and left 2, and that would be the square above AB, okay? I want to draw the one below. Okay, so let's go. Down 6, right 2, so 1, 2, 3, 4, 5, 6, right 2, 1, 2, here we go. So this is going to be AB, X, Y, this is going to be Y. And I'm going to do the same with B. 1, 2, 3, 4, 5, 6. 1, 2. Here we go. And this is X right here. So this is just playing with the perpendicular slope. All right. So now let's do it analytically. So Y equals, so you're going to take A, which is 4 and 3, and you're going to, so the run is on the X, right? So you're going to add 2 to the X, and you're going to subtract 6 to the Y. And so Y is 6, negative 3. We could also read it, okay, but I want to do the algebra. All right, and X, for X, you're going to take B, which is negative 2 and 1. And you're going to run on the X and drop on the Y, and so it is 0, negative 5. Here we go. Alright, so my first part is done, and now I am asked to find the equation of the circle that is inscribed. So the circle that is inscribed would be something like this. I'm going to try to quickly, something like this, inscribed circle. And then the circumscribed circle. So the inscribed circle is tangent to all the side, while the circumscribed circle is containing all the vertices of the square. Right here. Here we go. All right. Okay, it's not perfect, but that will do. Okay. Inscribed circle and circumscribed circle. Let's start with the inscribed circle. So for a circle, you need two things. You need the center and you need the radius. So where's going to be the center? Well, the center for both actually is going to be the same. Okay, these two circles are concentric. They have the same center. Where are you going to find the center? You're going to find it in the the center of the square, although we don't define this, right? But this is the midpoint of the diagonal, or where the diagonal intersect, which is the same. So I'm going to take a diagonal, and I'm going to take the midpoint of it. So basically, I want the midpoint of AX. Okay, so midpoint of AX. All right, so midpoint of segment AX, segment AX. So what is it? So A is 4 and X is 0. 4 plus 0 over 2, average of the X. And the Y coordinate of A is 3. And the Y coordinate of X is negative 5. 3 minus 5 over 2, average of the Y. And so the center is 2 and negative 1. All right. Let's see, let's check if we're right. Yeah, it's about that, right? 2, negative 1. Okay, right here, that's my center. All right, let's get the equation of the circle now. Let's start with the inscribed circle. So we'll have the inscribed circle. And then we'll do the circumscribed circle. Circumscribed circle. Okay, well, they both start in the same way. They will start as x minus 2 squared plus y plus 1 squared. Okay, because the center for both is the same, so that's how they begin. Plus y plus 1 squared. Okay, now I need the radius. So what is the radius of my circumscribed circle? Well, you will find it here, right? That would be the easiest. Or here, or here, or here. And this is what? Well, this is just half a side. Half a side. It doesn't matter what you take. So let's check out the length of the side AB. So AB is square root of, so XA minus XB, well, that's just the run, right? So it's 6 squared. YA minus YB is the rise plus 2 squared. So it is a square root of 36 and 4, 40. Square root of 40, but you have to divide it in 2. So let me take a 4 out, which is 2 root 10. And if you divide that in 2, then AB over 2, AB over 2 is just root 10, right? And this is going to be half the length AB, so this is your radius of the inscribed circle, and therefore the equation is equals 10. Here we go. Here's the first one. Let's get the second radius. Now the second radius, you will find it right here, the distance between the center and one of the vertex, or right here, or right here, or right there. So to find my radius, I will use the point X and the center. And so it is 0, negative 5, and 2, negative 1. So what is the distance between 0, negative 5, and 2, negative 1? So the distance is 2 minus 0, 2 squared, 4, plus negative 1 and negative 5, so that's a 4 squared, 16. It's a square root of 20. You don't need to simplify it because you need to square it right here. And so it is x minus 2 squared plus y plus 1 squared equals 20.